Hi, this is Marwa, and today we will be discussing how to find solutions of systems of equations. We will be discussing linear systems, which contains only two lines, and how to find the solution of that. Now we will go through how systems are represented by graphing, the different types of solutions of systems, how to solve systems using substitution and elimination, and we will go through a couple of word problems where you can see how to change the word problem into a system of equations that you can solve to find the solution. So by the end of the video, you will have everything you need about the basic solutions of systems of linear equations. So let's look at the types of solutions of systems of linear equations. Now, before we go through how to solve the systems, let's discuss what do we mean by solution of a system. First of all, the system is more than one equation. Now, in this case, we will be solving systems of linear equations. There are other cases where you have systems that are of linear and non-linear equations. So there could be two different types of equations, maybe quadratic with linear, maybe two linears with a quadratic. Like, there are tons of types of systems. When we discuss the solution of a system, it means you are looking for the point of intersection between the equations you have. So in this case here, I have two linear equations. When you are asked to solve the system, you are actually looking for the point of intersection between these two lines. Now, these two lines are represented on the graph here. We will go through how they graphed them, how they were graphed, so you get an idea on how to do that. Now, the first equation here, the one in red, is represented in red also. This is our first equation. Now, we can look at its slope or gradient. Sometimes it's called gradient. The slope is the number multiplied by x, as we have discussed before in the slope-intercept form of linear equations in a previous video, y equal mx plus b. So the number multiplied by x, and it's 1 in this case, is the slope, and the number added at the end is the y-intercept. The slope here is 1, and the y-intercept is equal to 2. Now, slope is usually rise over run, so we only have 1, we're going to put that over 1. This line is represented by here, this red color in the graph. How did they graph this line? It's pretty simple actually. You start from the slope, which is 2 in this case, so this is your first point. You're going to take the rise, which is 1, you're going to go up 1, then the run, which is also 1, so you're going to go to the right one. Now you have 2 points, connect them, and extend in both directions until you get this red line. So the first line, slope, was 1, or gradient was 1, and the y-intercept was 2. For the second line, the one represented in blue here, we have a slope or gradient which is equal to 3, and make that 3 over 1, and the y-intercept which is equal to negative 2. To graph it again, they started at negative 2. It's a y-intercept, so it has to be on the y-axis. You start at negative 2, you go up using the slope or gradient 3, 1, 2, 3, then to the right one, this is the second point, connected together, you extend the line. Now, when both lines were extended, they met in a point. This is the point of intersection, and the point of intersection here, this is the solution of the system. So this system has one point of intersection, which means it has one solution. Why one solution? 1 point of intersection. Okay? If we look here at the slopes, we had different slopes and we had different y-intercepts. Let's look our next system. Now, the next system consists of two different equations. One of them is in slope-intercept form, the second one, which is in blue again. So the blue one, I know that its slope sorry, is equal to half, and its y-intercept is equal to 1. What about this first equation here? Now remember, we said that if the equation is written in standard form, then the slope is equal to negative a over b. However, I'm sorry about that. It is much better that we change it into slope-intercept form to see how it works. How do I change into a slope-intercept form? I want to isolate y, so I'm going to take x to the other side. So you're going to have 2y equals x plus 2. You're going to divide everything by 2. You will end up with the equation y equal half x plus 1. So this equation became y equal half x plus 1, which is exactly the same like the first equation. So when you graph both of them, you will end up with the same line, like you will graph the exact same line twice. So this is actually not two different lines. These are two equations of the same line written in two different forms. This is why we say that this system has infinitely many solutions. If the first line, well, I should represent it with another color, but if the first line was represented in red, its slope that we have just found was half, and its y-intercept was 1. So if you check here, you will find that both lines had the same slope and the same y-intercept. So they are exactly on top of each other, which means that they act like the same line, both of them. So any point on that line is a solution of the system. This is why, because any point is on both lines, and this is why we say that this system has infinitely many solutions. Any point on those lines is a solution for the system. So it doesn't have one solution or two. It's not possible to have two. It has infinitely many solutions. Now let's look at our last system here. Now in this system, the first equation, we have the slope is equal to 2 and the y-intercept is also equal to 2. What about the blue line? The blue line had a slope of 2 also, and the y-intercept equals to -1. Now when you graph those two lines, you will see that both lines are parallel to each other. If these two lines are parallel, they will never meet. They will never intersect in a point. If they don't intersect ever, it means this system has no intersection point, which means this system has no solution. So again, if we look back at what we have so far, we have 3 different types of solutions of systems. The first type, 2 lines intersecting in one point have one solution. If we look at these 2 lines, we'll find that they have different slopes. They also have different y-intercepts, but if they have the same y-intercept, it means this was their intersection point. So the only thing I want to emphasize on here, that these 2 lines had different slopes. If they have different slopes, they will intersect in a point. Even if you don't see it on the graph, then you need to extend or make a bigger graph. Now, if the 2 lines had the same slope, like in this case, and same y-intercept, then they are exactly the same line, so the system has infinitely many solutions. If the 2 lines have same slopes but different y-intercepts, this here was a -1, sorry, it's not written, it had different y-intercepts, then the system has no solution, because any 2 lines with the same slope are actually parallel. If they have the same y-intercept, they're not only parallel, but they are the same line. Different y-intercept, then it has no solutions, because these 2 parallel lines will never meet. Okay, so even without graphing, if you see different slopes for a system, you know that the system has one solution. If you see the same slope, there are 2 cases. Same slope, same y-intercept, infinitely many solutions. Same slope, same y-intercept, infinitely many solutions. Same slope, different y-intercepts, then your system has no solution. Now let's move further. How do I solve a system from a word problem? Now in this word problem here, we have a question asking us about geometry. Now it says here the measure of one acute angle in a right triangle. So I already have one of the angles, which is 90 degrees, before we go further. But I have another acute angle. Is 4 times the measure of the other acute angle. So I'm talking about two different acute angles. One of them is 4 times the measure of the other. Write and solve a system of equations to find the measure of the acute angles. So I want both of them. Before you do anything, always define a variable. So let x equal the measure of the first acute angle and y equal the measure of the second acute angle. Okay? Now what do I know about them? I know that one acute angle, the first one, in that right triangle is 4 times the other one. So I can write the first equation here. X is equal to 4y, and this is my first equation. Okay? Now where do I get the second equation? We know it's a right angle triangle, so one of the angles is 90. This means the sum of the other two angles has to also be 90, because any triangle has an angle sum of 180. We take away that 90, then we can say that the other two angles, the sum of both acute angles, is equal to 90 degrees. And this here is your second equation. Now I have the system, first one representing that the first angle is 4 times the other one, and the second here says that both angles together will make 90 degrees, the measures of both angles together. Now I want to find both of them. What do I do? We are going to solve this system using substitution. What do you mean by substitution? I know the value of x in terms of y. Like I don't know it as a number, but I know that it's equal to 4y. So why don't I just take those 4y and put them here instead of x? And this is what we mean by substitution. This is x and this is also x. So I can remove this x and put 4y in its place. And this is what do we mean by substitution. So I'm gonna substitute in equation number 2. I'm gonna use equation 1 to substitute in equation number 2. Equation number 2 here was x plus y equal to 90. I'm gonna remove the x and I'm gonna put 4y. And I'm gonna write the rest. So 4y plus y equals to 90 degrees. Well, now it's easy. Combine like terms. I have 5y equals 90 degrees. I'm going to divide both sides by 5. I will end up with y equals 18 degrees. Now I have the value of one of the angles. I need the other one. So what do? I'm going to take that y and substitute again in any of the equations. I know the relation between x and y. So I can use the value of y to get x. Now, which equation do you substitute in? It does not matter. You can substitute in the first equation or in the second equation. So let's check that out. I'm gonna substitute in equation 1 and find the value of x after I know how much y is. So I'm gonna have x equal 4, and that's multiplied by the value of y we just found, which is 18. Then I can tell that x after multiplication is equal to 72 degrees. I found the value of x. You know what? I'm going to show you how to substitute in the second equation, and that it's going to end up the same result. Now, when you're solving, you don't need to do both. You can do one of them. I'm just showing you that regardless which equation you're going to substitute in, you are going to end up with the same answer. So x is here. I'm going to substitute in the second equation. I'm going to remove y and put the value of y, which is 18. So I know that x plus 18 is equal to 90. I'm going to subtract 18 from both sides. You will end up again with x equal 72 degrees. So the measures of the two angles are 72 degrees, which is the bigger angle, and 18 degrees. Again, when you're solving this alone, you can only substitute in one of the equations. So what do we do in this method, the solving systems by substitution? You are going to use one equation, isolate the variable. In this case, we already have it isolated. Any variable, like I have x equal 4y. So I know the value of x in terms of y. I can remove x from the second equation and put its value. In this case, you will have an equation with one variable that you can solve. Why do we do this? There is no way for anyone to solve one equation with two different variables. It has to be one variable for one equation for you to be able to solve it. If there are two variables, then you need two equations to be solved together. If there are three variables, we need three equations to be worked out together. Okay? So this was solving systems by substitution through a word problem. Now we will solve systems by elimination through another word problem. This word problem here says that the theater club sells a total of 101 tickets to its first play. A student ticket costs $1. An adult ticket costs $2.50 or $2.50. Total ticket sales are $164. How many student tickets are sold? Now, my advice to you, again, although it's a multiple choice question, define the variables. So let x equal the number of student tickets and let y be the number of adult tickets. I'm sorry, like I'm abbreviating things just to save time. Okay, so I know that x is the number of student tickets and that y is the number of adult tickets. Now if you look here, the cost of a student ticket is $1, so I can multiply 1 by x plus adult ticket costs $2.50, so 2.5, you don't have to write the 0 now when you're solving, is multiplied by y. And together, how much was that? It was, the total sales was $164. Take care, in this equation, you're gonna put dollars with dollars with dollars. This 101 cannot go into this equation because it's not of the same unit. When I multiply $1 by x students, you will get amount of money. When you multiply $2.50 by y adults, you're still gonna get amount of money. When you add both amounts together, your solution has to be also an amount of money. So the whole equation has to be of the same unit. Now, what about the second equation? They said here the theater club sells a total of 101 tickets. So I'm talking about the number of tickets here. And I already said that both my variables represent numbers of tickets. So here I'm gonna say x plus y, total number of students' tickets plus total number of adults' tickets, should be 101. Now, this system is a system that can easily be solved by elimination. What do you mean by elimination? Elimination is when you have two equations and one of the variables has the same coefficient, like x here is multiplied by 1, x here is also multiplied by 1. When you have that, you can actually eliminate one of those variables, omit it, just remove it. How? By subtracting both equations. So I can just subtract the equations. Sorry about that. So I can just subtract the equations. What do I mean by that? 1x minus 1x is 0, so I'm not going to write anything here. 2.5y minus y, that's 1.5y. And 164 minus 101, that's 63. I made an equation by subtracting the system I have and eliminating or omitting the value of x, because both x's had the same coefficient. Okay, now I'm going to solve the equation I have, divide both sides by 1.5. You will get that y equals 42. Well, 42 is one of the choices, but take care. Y equals 42 is the number of adults' tickets. And this is not what the question wants from you. They want the student tickets. So you cannot stop here. We have actually to substitute in one of the equations to be able to find the value of x. This is equation number 1 and this is equation number 2. Same way we did when we were solving by substitution. So I'm gonna substitute in the easier one. We agreed that regardless which one you substitute in, you're gonna get the same answer. So I'm gonna substitute in equation number 2 just because it's easier. Question number 2 states that x plus y is equal to 101. I don't have the value of x. This is what I'm looking for, number of student tickets. I only have the value of y, and I am going to substitute for y equals 42, and together they should make 101 tickets. Subtract 42 from both sides, you will end up with x equal to 59. So the number of students' tickets sold is 59, which is choice C. So take care, because usually when you have choices, especially in standardized testing like SAT or MAP, you will find that they will put the wrong solution for you in the choices. So you could have stopped here thinking that you have found the answer if you didn't read the question very well. Now, I hope this has been helpful. In this video, we went through the system of equations of 2 lines, only 2 linear equations. We discussed the case where we have one solution, infinitely many solutions, or no solutions at all. We have discussed how to solve systems using elimination and substitution, and we have done that through word problems, so you can easily try to get the information from the word problem and change it into a system of equation you can work with. I hope this has been helpful, and thank you so much for watching.